Hello, welcome to the online Let's Review for Science. Before we start, let me introduce myself first. I am Elisar V. Malikoban, a licensed professional teacher, a professor in the College of Education, MSU IIT. Here in Science, we're going to cover four major fields. And the first part is physics. So let's get started. Number one, teacher Anne showed the class the potted plants placed on the window sills. She asked them to observe the direction of their growth. The pupils observed that the plants tended to grow outward. Then teacher Anne asked the class this question. Why do you think they grow outward? What was teacher Anne engaging the pupils to do? The answer is letter D. Scientific method has four general parts. Number one, observation, identifying and clearly defining the problem. Two, hypothesis, formulating a working explanation or an intelligent guess about the problem. Third, experimentation, conducting controlled attempts to test one or more hypotheses, which includes recording and analyzing results. Lastly, conclusion, formulating a generalization about the results which may accept, reject, or modify the hypothesis. It is a cycle because if ever the result did not meet your expectation, you may go back to the first step. Number two, which of the following is a fundamental unit? The answer is letter D. Fundamental quantities are base quantities, and derived quantities are combinations of fundamental quantities. There are seven fundamental quantities. These are length, mass, time, temperature, electric current, luminous intensity, and amount of substance. And each of those quantities has a fundamental unit as well. So for luminous intensity, the fundamental unit is candela. While the derived quantities on the right side are the following: area, volume, density, speed, force, energy, etc. Number three, a car is moving at 10 meters per second north, which is a vector quantity. The answer is letter C. Scalar quantities are quantities with magnitudes and units, while vector quantities are quantities with magnitudes, units, and directions. Take note that all those seven fundamental quantities are scalar quantities. However, some of the derived quantities are scalar quantities like area, volume, density, and speed. And some of those derived quantities are vectors like force. Number four, the orbiting motion of the planets around the sun is an example of A, and the answer is letter D. When you say motion, it is a change in position of a body with respect to a fixed reference point, which can be classified as linear, also called rectilinear motion, circular, movement along the circumference of a circle, vibrational, the back and forth motion, elliptical, motion in an oval-shaped path called ellipse. An example of this is the orbit of the planets in the solar system. Lastly, projectile, motion in a parabolic trajectory. Number five, how fast an object is moving in a particular direction is described by, the answer is letter B. Motion can be described in any of the following. Distance, that is the actual length of path taken by an object in moving from its initial position to its final position. Displacement is a straight line distance between initial and final positions with direction toward the final position. Speed, distance that a body moves in a unit time. And our answer for this item is velocity because it is the speed associated with direction. It is therefore a vector quantity. Finally, acceleration, change in velocity with respect to time. Number six, in which case is the car accelerating? The answer is letter D. When you say acceleration, it is defined as a change in velocity with respect to time. Velocity can change in three ways: change in speed, change in direction, and change in speed as well as direction. Any of those conditions will be attained, then there is acceleration. So in this item, A, B, C options show acceleration. So the answer is all of this. 7. A coconut falls freely with a constant acceleration of 9.8 meters per second squared. What does this mean? The answer is letter D. The gravitational acceleration or the acceleration due to gravity for objects falling near the Earth's surface actually varies slightly from point to point on the Earth's surface because of differences in altitude and other effects. An object that falls freely with a constant acceleration of 9.8 meters per second squared means that the speed of the object increases 9.8 meters per second every second. 8. Which one exerts the greatest gravitational force on you? The answer is letter A. Gravitational force is one of the fundamental forces of nature. Gravitational force is responsible for the motion of the bodies on Earth and motion of the planets. Electromagnetic force holds atoms and molecules together. Strong nuclear force holds the constituents of the nucleus together. And weak nuclear force plays a role in the radioactive decay of some nuclei. 9. An object is sent out of space. Which of the following statements is true of this body as it moves away from Earth? The answer is letter B. Mass is defined as the amount of matter in an object, while weight is the force with which a body is attracted towards the center of the Earth. If an object is sent out of space, the object's mass remains constant and its weight decreases. Number 10. Riders in a motorcycle are pushed forward during a sudden stop. Which law of motion provides an explanation? The answer is letter D. According to the Newton's first law of motion, known as the law of inertia, an object remains at rest or in uniform motion in a straight line unless it is compelled to change by an externally imposed force. When we say inertia, it is a property of a body that tends to resist a change in its state of motion. 11. Suppose you're pushing a car with a certain net force. If you then pushed it with twice the net force, the car's acceleration would. The answer is letter B. According to Newton's second law of motion, or the law of acceleration, the acceleration of an object is directly proportional to the magnitude of the imposed force and inversely proportional to the mass of the object. So if you push the car with twice the net force, the car's acceleration would become twice as much. 12. An unfortunate bug splatters against the windshield of a moving car. The force experienced by the bug is. The answer is letter C. They will have the same force. It is stated in the Newton's third law of motion, that is a law of interaction, that if object A exerts a force on object B exerts a force on object A that is equal in magnitude but opposite in direction to the force exerted on B. 13. Which simple machine is represented by a doorknob? The answer is letter B. It is a wheel and axle. When you say simple machine, it is any mechanical device that multiplies the effect of an applied force. So you can see there in the table, those are examples of different simple machines like inclined plane, wedge, lever, screw, pulley, and of course, the wheel and the axle like doorknob. 14. A job is done slowly and an identical job is done quickly. Both jobs require the same amount of length, but different amount of length. The answer is letter D. Work is defined as a product of force and distance the object moves under the influence of that force and in the direction of the force. When you say power is the rate of doing work. Based on this question, both jobs require the same amount of work because the jobs are identical. However, the job that is done quickly requires more power because of less time. It can be observed in the formula that power is equal to work divided by time. If you look at the formula, you can say that power is directly proportional to work and power is inversely proportional to time. It means that the greater the work done, the greater the power. The greater the time, the less the power, because power is both how much work you do and how fast you do it. 15. A ball is thrown vertically upward at its maximum height. Blank. The answer is letter D. When you say potential energy, it is the energy due to the object's position and configuration, while kinetic energy is the energy due to the object's motion, meaning potential energy depends on the position or the configuration of the object, while kinetic energy depends on the speed of the object. When a ball is thrown vertically upward, the ball will possess maximum potential energy because of maximum position at the highest point with respect to the thrower's hand. When a ball is thrown vertically upward, it will stop at a very short moment of time when it reaches the highest point. So it will possess zero kinetic energy. 16. How is a conservation of mechanical energy described in a falling object? A falling object blank kinetic energy and blank potential energy. The answer is letter C. Again, when you say potential energy, it is the energy due to position, and kinetic energy is the energy due to the object's motion, or it depends on the speed of the object. The answer in this item can be explained by this example. So for example, you're riding a roller coaster. As a coaster car loses height, it gains speed because of the pull of gravity, while the potential energy is transformed into kinetic energy. As a coaster car gains height, it loses speed. Therefore, the kinetic energy is transformed into potential energy. Now, let's go back to the to the object as it goes down. As the object goes down, it is being pulled down by gravity. It is expected to increase its speed. Remember, the kinetic energy depends on speed, so while the object is falling, the speed is increasing, therefore the kinetic energy is increasing also. So that is why it gains kinetic energy. 17. The law of conservation of energy is a statement that blank. The answer is letter C. According to the principle of conservation of energy, if there are non-conservative forces doing work on a system, the total mechanical energy of the system, that is, the sum of its kinetic energy and potential energy, remains constant. That is why we usually hear that energy cannot be created nor destroyed. That can be explained by this pendulum. So you notice you have there from the bottom, the pendulum may possess kinetic energy if you're going to release it from a certain height. From a certain height, it possesses potential energy, the energy at rest or with respect to position. But if you're going to release the object, the potential energy will transform into kinetic energy at the bottom because it will gain speed. And later it will go to the other side, it will gain potential energy because it will also have position, and so on. 18. A rectangular block of steel has dimensions of 5 meters by 10 meters by 15 meters and weighs 1,000 newtons. How should this block be placed on a surface to exert the least pressure on the surface? The answer is letter D. When you say pressure, it is the ratio of the force of the area over which it is applied. In mathematical expression, pressure is equal to force divided by area. So based on that formula, you can say that pressure and force are directly proportional, while pressure and area are inversely proportional, meaning the greater the force, the greater the pressure. The wider the area, the less the pressure. Let's take a look at this example. If you're going to push your hand with a thumbtacks using a particular or certain amount of force, like 10 newtons, and you're going to push it using the wider area, then it may experience less pressure. But if you're going to use the sharp edge of the object, then surely it will hurt you because of a smaller area creating a bigger pressure. That can also be explained by the second example there. No? If you notice, the shoes of the man remain on the ground while the heels creates create something on the soil because of the pressure created by the heels. So in this item, the answer is letter D because 10 times 15, 10 meters times 15 meters, you have 150 square meters. That is the widest area among those four options there. 19. Why is a dam built wider at the bottom than at the top? The answer is letter A, to withstand the greater pressure at the bottom. The pressure in a fluid, when you say fluid, that can be liquid or gas. The pressure in a fluid increases with depth. Let's take a look at these examples. The first illustration there, you have there air. Air is composed of actually air particles that we cannot see. But if you try to look at those particles from the highest position going to the bottom, you notice that there are more particles at the bottom. Why? This is because those particles are being pulled down by gravity. So you notice there are more particles at the bottom than at the top. Now each of those particles is exerting force on the area of the air. So since there are more air particles at the bottom, it is expected that there would be greater force at the bottom than at the top. Then that creates increasing pressure from the top to the bottom, meaning as you go down in the air, the pressure is increasing. As you go up, the pressure is decreasing. That is the same story when you are in water. Water is also classified as fluid. Just like the air, you cannot see the particles of water or liquid. The same story, the particles of liquid are being pulled down by gravity, so there are more water particles at the bottom, creating more force at the bottom, therefore greater pressure at the bottom. Just like in air, in water also, the pressure increases with depth. Number 20. What factor is responsible for objects' loss of weight in liquid? The answer is letter C, the buoyant force. When an object is submerged, its volume takes up space occupied by water. It displaces the water, in other words. The more water displaced by the object as you push downward, the greater the upward buoyant force. This is the Archimedes principle, which can be stated as the buoyant force acting on an object, fully or partially submerged in a fluid, is equal to the weight of the fluid displaced by the object. 21. Which has greater density, a lake full of water or a cup full of water? The answer is letter C. They have the same density. Density is defined as the ratio of mass. Mass is the amount of matter to volume. Volume is the space occupied by matter. So you can express that in mathematical symbols. You have rho. Rho stands for density. M stands for mass. And V stands for volume. So you can see there in the formula that density is the ratio of mass and volume. Density is also, it means how tightly packed matter is, the amount of mass in a given space. So you have there gas, liquid, and solid. These are three different physical states of matter. So you notice that gas is less dense than solid is more dense. That is because if you're going to look at the illustration, you would see that there are more particles in solid at that particular space than the particles of gas. That is why solid is denser than gas. However, if you look at the formula, mass actually depends on the quantity of matter. Volume also depends on the quantity of matter. However, the ratio between the two will give a property that is intensive, which is density. It means that it does not depend on the quantity of the material. 22. The density of fresh water is 1 gram per cubic centimeter, and that of seawater is 1.03 grams per cubic centimeter. A ship will float. The answer is alpha, letter A, lower in fresh water than in seawater. The reason for this is no other than salt. Because of the salt dissolved in the sea has higher density than the river. So, it is expected that the ship will float lower in fresh water than in seawater. Because seawater is denser than fresh water, like 23. The degree of hotness or coldness of an object is measured in terms of its. The answer is letter C, that is temperature. Temperature is a degree of hotness or coldness of an object. Latent heat is defined as the heat required to convert a solid into a liquid or vapor, or a liquid into a vapor without change of temperature. Specific heat capacity of a substance is defined as the heat capacity of a sample of the substance divided by the mass of the sample. And thermal conductivity of a material is a measure of its ability to conduct heat. 24. When a vapor condenses into a liquid, blank. The answer is letter B. It evolves heat. Condensation is actually defined as the change of the physical state of matter from the gas phase into the liquid phase. It is the reverse process of vaporization, in which the liquid phase changes into the gas phase, wherein heat is being absorbed. Now take a look at the illustration. You have there on the horizontal axis, you have there the heat, on the vertical axis, the temperature. You notice that if heat is added to a system, then there is a forward process wherein solid becomes liquid, liquid later on becomes gas. Take note that is when heat is added to the system. So for example, when heat is absorbed by the system, the solid will undergo melting. It will become liquid, and that heat is what we call the latent heat of fusion. Later, if the heat is continuously absorbed, the liquid will become gas. So there is another form of heat that is being absorbed. However, if heat is being released or evolved from the system, then it becomes a backward process where gas becomes liquid and liquid goes back to solid. So condensation is an example of a backward process because gas goes back to liquid. 25. A small jar is filled with ice and then covered tightly. The outer side of the jar is dry with a piece of cloth. After 5 minutes, the outer side of the jar becomes wet. Where does the water on the outer side of the jar come from? The answer is letter A. Water vapor in the air condenses on the outer side of the jar. Recall condensation, which is defined as a change of the physical state of matter from the gas phase into the liquid phase. So probably the air that surrounds the jar goes back to the liquid phase, and you call that condensation. That is why you can see those droplets of water outside the jar.